Okay, so çalışıyor herhalde. Evet. Alright, so the last time we discussed the following. So this is a vector space over a field K. We define the view vector space, which is just denoted homomorphisms from view K. K linear homomorphisms means that and we did the following. In case dimension of V is equal to n and beta E1 up to En, a basis for V, we define so-called dual basis E1 star up to En star. We call this dual basis for V star, but of course this needs a proof. This is a claim, right? This is the basis. Is a claim. We haven't proved it. What are those digits? So E I star is a homomorphism from U to K, and how this is defined? This is defined as follows: EI star and EJ. It is enough to define a homomorphism on a set of basis elements. So if I just tell you what the values of this guy at any basis element, then this homomorphism is defined. And the value of this is defined to be the chronicle delta Ij, meaning that it is 1 if I is equal to J, 0 otherwise. Okay. I guess I have done one example where we constructed all this E1, E2, and so on. If you want, I can do one more example. Let us, for example, consider the following vector space. Let's say R2, 3 by 1 vectors. So things like this, X, Y, Z. X, Y, Z, across 3 numbers. And let's say we are given a basis there. Okay, let me choose this basis. 1, 0, 1, and then 2, 1, 0, and minus 1 and 0, 1, 3. Okay. Öldürürsem 2 ile çarpıp of course, this needs a proof also, but I just skip it. Okay? In the exam, I can ask you, show you this is this. We have to prove 2 things. First, any vector can be written as a linear combination of vectors, and these are linearly independent. 6 or 0. 0. Evet.
Ben bir soru soracağım.
Sor.
Biz bir tane teorem öğrendik yani. Eğer verilen isimlerin ya da işte verilen base'lerin işte o şeyin
Set of vectors.
İşte en eşitse
Tamam.
değil.
Evet, tamam.
Mesela bu soruda sen hiç kontrol etmeden dimension'ın çeşit olduğunu
Biliyorsun.
ve linear ve doğrunu kanıtlarsan ve doğrunu kanıtlar çok yanlış yeterli yani sen
Yeter.
göstermeme gerek yok.
Evet. Ama onu belirtmen lazım. Tamam mı? Evet. So this is the basis because it is linearly independent ya da space set demiştin sen. Because it spans R3 and dimension of R3 is just 2. Span ettiğimizde nereden söylüyorsun? Span because if you choose any vector, let's say A is C, I can write it in this basic, right? How?
We can coefficient of these rays.
Yeah.
Maybe
Yeah, in this question it's not very easy. Okay. But we can do this C1, C2, C3. 1, 0, 0, 2, 1, 1, 0, 1, 3. And then we have one. Okay, Q1 plus C2 is equal to 8, right? And C2 plus C3 is equal to B minus C2 plus 3C3 is equal to C, right? Just multiply and make them up. The first coefficient is, this is just Q2. And this is C1 plus 2C2, C2 plus C3, and minus C2 plus 3C2, right? So this is A, this is B, and this is C. And from this, you can solve for C1, C2, C3. How? For example, just look at this two. If I make them up, we get what? When you add this two, you get 0, and here you get 4, C3 is equal to B plus C. So C3 is just B plus C over 4. Okay, so this is B plus C over 4. And then C2 is what? C2 is B minus B plus C plus 4. Yani nedir? 3B eksi C bölü 4. So C2 is 3B minus C over 4. C1 ne olacak? C1 için sadece buna baksam yeterli, değil mi? Bunun iki katı, bunu ekleyince, evet, şuradan yapalım. C1 plus 2 times C2. 3B minus C over 4. Ya da şöyle diyeyim, 2. Evet, 2'yi çarptık. That's equal to A. So C1 is equal to 2A minus 3B plus B over 2. Right? So 2A minus B, 3B plus C over 2. So we have shown that it's a spanning set, and once it's a spanning set, then it will be a basis. Tamam mı?
Hocam burada spanning yerine linear independent olduğunu gösteriyor.
Okay, o da olur. Of course, here this bit has 3 elements and this has dimension 3. Therefore, any set, in this case, if this is linearly independent, it is automatically spanning, and if it is spanning, it is automatically linearly independent. Çünkü linearly independent olmasa, if it wasn't linearly independent, it would mean that one of the vectors can be written in terms of the other 2 vectors. Then you would throw the linearly dependent one, but you would end up with 2 vectors spanning the whole space. And that would be a contradiction because in that case, dimension would be 2. But it says dimension 3. Okay. All right. Now, what about the dual basis? So, I guess we will make this so E1 is this vector. Let me just E2 is this vector 2, 1, minus 1, and E3 is this vector 0, 1, 3. E1, 3 is a vector, is a covector or dual vector, which takes the value 1 on this and 0 on this guy, right? So, what is the value of this on ABC? Wow, this is E1 star, C1 E1, C2 E2, C3 E3, right? Yeah, this is linear, and ABC written like this, right? C1 E1, C2 E2. This is my C1, this is my C2, and this is my C2, right? I wrote ABC as C1 times E1, C2 times E2, C3 times E3. And now I just write it down. Now, since this is linear, this is just C1 times E1 star E1, C2 times E1 star E2, and C3 times E1 star E2. But I know that this is 1 and this is 0 and this is 0 by definition. Therefore, the answer is just C1. So it means what? C1 star on this vector takes the value C1. What was C1? 2a minus 3b plus c. 2a minus 3b plus c over 2. Similarly, what is E1? No, E2 star of A, B, C. That would be just C2, right? This is E1, this would be C2. And what is that?
3 minus all.
And E3, this linear map on the vector A, B, C is just C3, which is just E plus 2. So we have determined E1, E2, E3. Tamam mı? Yani o yaptığımızda boşa gitmedi. Yoksa şimdi yapacaktım. Oradaymış. Okay. What we claim is this. What we claim or is a proposition. In case our vector space is finite dimensional, V star is a basic data star, which is E1 star, En star is a basis for V star. In particular,
dimension V and dimension V star are the same. But again, as I told you last time, this is not true if D is not finite dimensional. Okay. Remark. Ve doğru sonra yazayım. Yazdım. Örnek göstermedin ama değil mi? İyi, ona örnek yapalım o zaman bir tane. Evet. Proof. Well, at this moment, I don't know what is the dimension of B star. B star is a vector space which we defined. So we are trying to prove this. I haven't proved that this has dimension n. Therefore, we have to really show that this is a spanning set and it's also linearly independent. Okay. Therefore, this will be a basis for B star. And since it has n elements, these two will be equal to each other. So let's do that. First is linearly independent. Well, why is that? Let's P1 star, Pn star equals 0 for some C1 up to Cn in K. So we have to show what? Must show C1, C2, Cn are all equal to 0, right? That's what I need to show. Linearly independent means this. Any linear combination which is equal to 0 should imply that all these coefficients are 0. In other words, the only linear combination of these vectors which is equal to 0 can be obtained by choosing this constant as 0. Otherwise, it won't be 0. Now, why these are 0? Well, it's very simple. This is 0 means this is a map, right? This is a linear map. This linear map is 0 means it takes 0 at all vectors, right? So let's denote this linear combination. And this is 0. So as a linear map, F takes the value 0 at all vectors. So F of B is 0 for all B in B. Well, if it is 0 for all B, it should be 0 for the basis vectors also. Hence, F of EI should be 0 for all I when none of them, right? But what is F of I? So this is 0. F of I. This is just C1 E1 star, Cn En star, evaluated at the vector EI. These are functions, right? F plus G plus H plus K plus whatever. Several functions added up, and you want to compute the sum at this point. This is the same thing as C1 E1 star evaluated at E1, sorry, EI, and so Cn En star evaluated at the vector EI. Now, what are these values? Well, so I have, okay, let me F of UI. This is just U1 star UI, and it goes up to height element. But you see, EI, E1 star evaluated EI is just 0, right? Because these indices are not the same. Next one is 0, next one is 0, only this one is 1. Then these two indices are the same. And again, this is 0. So there is only one non-zero term, and it is 1, and the coefficient is just CI. So what we think, CI is just 0. So this is exactly what we want. So CI is 0. And here I can be anything from 1 to n. Therefore, this is for all. And this is exactly what we need, right? I took this linear combination. Which is equal to 0, and we showed that in that case all these coefficients are 0. Hence, this set is linearly independent. Okay. What about the span business? So, second thing we need to show is that spans in span. So this means any vector or covector in this star should be a linear combination of these AIJs. All right. Let F be any element here. Okay. Well, let lambda I be the value of this linear map, right? F is a linear map from okay. F is just then F is just a linear map from METU. Okay. I can compute this at the basis elements. Let this number to be lambda I from 1 up to n for some lambda i's in K. And if I compute F at the basis elements. We know that any linear map is uniquely determined on its by its values on the basis elements. So this F is uniquely determined by these lambdas. Now I would write down another map which takes the same values at the basis elements. So let G to be this linear map. Lambda 1 times E1 star, lambda n times En star, which is again a linear map, right? So it's a covector. And moreover, what is G of I? Well, when you plug G of okay, E1 star, E1 star, evaluated at EI. What is the value of this? E1 star will evaluate 0, E2 star will evaluate 0, EI star will evaluate 1, and its coefficient is lambda I. Therefore, this will be just lambda. So what we see are from 1 up to n. What we see is the following. This linear map and this linear map takes the same values on any basis elements, right? Therefore, these two linear maps are the same. Okay. Yes.
How do you know the element of the star?
Well, these are linear maps. Some of the linear maps are linear. It's quite different. Okay. So here, what you ask is a nice question. Maybe I didn't prove that. Linear maps, if you take two linear maps, their sum is also linear. So your friend is asking this. Suppose A heads from V to W and 3 heads V to W are two linear maps. Like this one. This is a linear map. This one is a linear map. I add them up and again we obtain a linear map. Why is that? Because if you have two linear maps, then A head plus C head. This is a map from V to W. That's clear. How it is defined? We take the vector and we just send it to this, right? The question is this linear, is A head plus B head linear? Well, just check it. I mean, it's easy. You have to prove two things, right? A head plus B head, V1 plus V2. Well, by definition, it's just A head plus a head of V1 plus V2, and this is B head of V1 plus V2. But since a head is already linear, it's a head of V1, a head of V2, and then B head of V1 and B head of V2. But now A head V1 and B head V1 means A head plus B head V1 plus the remaining two terms, this one and this one. This is just A head plus B head of V2. So A head plus B head on this vector is just A head plus B head on V1 plus A head plus B head on V2. And then of course one has to prove also the following. A head plus B head lambda times B. What is this? This is A head lambda B plus B head lambda B. And this is just lambda times A head B plus lambda times B head B. And this is just lambda times A head B plus B head B. And this is lambda times A head plus B head. Okay. It seems like I'm writing the same thing each time, but we are proving different things. Okay. What I'm writing is not the same all the time. There are slight differences, but they are very similar ideas. Well, how do we finish the proof? Now, so I have two maps, F and G, both linear maps, and they agree on a basis, then they are the same, right? Let me just write here. F equal G on beta, therefore F is equal to G. And F is equal to G means F is equal to this function. So F is a linear combination of E1 star, E2 star, E3 star, En star. Therefore, F is in this span of beta star. Right? So this means F is in the span of beta star. Okay? Because F is equal to G, and G is just linear combination of these vectors. Tamam mı?
Hocam orada eriştik bir o beta sağlaması.
Yok, beta. Bunlar beta tanımı. These are defined on V, therefore on the basis elements of V they are the same.
and that implies that these two linear maps are the same. That's a very nice thing, and actually the reason why we study linear maps, I mean, or linear algebra, to compare two maps, you don't have to check whether they are the same or not at each element of your vector space. It is enough to check that they are the same on a basis, right, on a set of basis elements. Yani normalde, in general, if you have two functions from R to R, two functions, let's say, how can you check whether they are the same or not? You have to check that these are the same at all real numbers, right? Uncountable many. But in case of linear maps defined on a vector space, you just check them on a set of basis vectors, finitely many, usually finitely many elements. Okay, that's the power of linear algebra. Tamam mı? Sorusu olan, inanmıyoruz bunlara diyen, bizi kandırıyorsunuz diyen. Evet.
Hani mesela ilk başta ne dedik? Şeyin içinde, listenin içinde dedik.
Hı.
Hani dili bir şey yok ya, bence ben onu söylüyorum.
Cinsler de burada neden? Burada
Neden ki onun içinde dedik?
evet. Ben listerin çünkü vektör sayı olduğunu tam yani buradaki şey linear maplerin toplamının linear olduğunu söylememiştim. Onu burada yaptım. Değil mi? Bu niye vektör? Why this is a vector space, right? These are linear maps. Why the set of linear maps is a vector space? Because you can add linear maps and the result is also a linear map, like this one. And you can multiply a linear map by a constant. That's also a linear map. Yani şu da, right? If A is a linear map, then number times A is also a linear map. That's why it's this vector space. Evet. Tamam mı? Peki. O zaman şey göstermiş olduk. So this finishes the proof. Therefore, these are V and V star has the same dimension. What about this dimension? Let me do one example, which shows that things are quite different. Okay, so we call it dimension view is the dimension in time. If view is infinite dimension. Let me give you an example which at least shows that this argument doesn't work. Meaning that if you have a basis of this, then the dual basis defined this way will not provide you a basis for this. Okay, so let's do that. Okay. The example below use some idea about this. Okay.
So let me be the vector space of all real polynomials. To the vector space of all polynomials with real coefficients. Then we have, you know that 1, x, x squared, x cubed, and so on. It's a basis, right? Then theta, which is 1, x, x squared, x to the power n, is the basis for you. Why it's a basis? Well, any polynomial can be written like this, is a linear combination of the elements, and they are linearly independent. They are linearly independent by the definition. And or you may consider that as functions on R. Yani polinomlar durumunda şey aslında bunların zaten polinomların tanımında in the definition of polynomials, if we have a polynomial, let's say px, which is a0 plus a1x and x0, this is 0 as a polynomial, if and only if a0, a1, an are 0. Okay, this is the this effect from the construction of polynomials, which we haven't actually done it, but just take this as a fact. Okay, from the construction of polynomials, if a polynomial and a polynomial is 0, if and only all coefficients are 0. Therefore, these elements are necessarily linearly independent. Okay. So this is a linearly independent set, and therefore it's a basis. Okay, we may consider the dual basis. Let me call this element E0. So let's call them E0 is 1, E1 is x, E2 is x squared, En is x to the power, and so on. What is the real set? This is the dual set. Then now consider this star, which is E0 star, E1 star, E2 star, and so on. So, for example, what is E2 star? E2 star, when you plug a polynomial A0 plus A1x plus A2x squared and x to the power, what is the value of this? Its value on 1 is 0, on x is 0, but on x squared, it is 1, therefore it's just A2. Okay, so they are defined this way. These are linearly independent, so let me do it as an exercise. This data chart is linearly independent. That's not the problem. The problem is that this step doesn't span restart. However, data start does not span this span. What is it? Well, I claim that not all the elements here can be written as a linear combination of elements from this. So I have to exhibit one such correct. Değil mi? Ne diyorum? Buradaki her vektör bunlar cinsinden yazılamaz. Nasıl ispat edersiniz bunu? Bir tane bulacaksın, değil mi? Böyle bir vektör. Şuna bakın. Define f from a as şöyle. It is enough to define this on basis element, right? You are start with one for all. Yani her bir basis elemanını bire götür. It takes all the basis elements to one. So what is the value of this, for example? On no, I should write right. In other words, x equals n is just one, right? For all. So what is the value of this on this element? It is just this will be mapped to A0, this will be mapped to A1, A2, A. So this is just A0 up to A1 up to A n. Right? Just the sum of all the coefficients. That's actually it. It's just A0, A1, A1. Aslında şöyle bir görebilirsiniz. This is just the value of the function. Polynomial function f1, right? So it's just p of 1. If we call this polynomial x, its value f1. This vector, covector, is not in the span of the I stars. Yeah.
No, it's in the girl.
Okay. Yeah. Okay. Exercise. It is the because it is defined by this rule, right? I mean, if you have f plus, so p plus q, f of p plus q will be f plus q at 1, but that will be f of 1 plus f of q of 1. But it's a nice question, so this is linear map. Therefore, f is x will start, but f is not in this. Span of data structure. Why is that? Proof is very easy. Suppose it is, okay? Suppose on the contrary, F is in the span of this digit. Well, is in the span of this means it's a linear combination of finitely many elements from this set. So it should be something like this. Lambda 1 times E1 star, lambda 2 times E2 star. Maybe some of them are 0, I don't care. But it should be written like this for finitely many elements. For some lambda 1 up to lambda and in K. Well, but then I'm sorry. All right, so we claim this F is in this star and F is not in the linear span, is in the span of this beta star. To prove this, we assume the negation. So suppose F is a linear combination of some finitely many elements in beta star. So it can be written like this. But then you have the following. Let's compute this on n plus 1. Right? The value of this guy is equal to 1. Why is that? Because I define it with them. Each basis element is mapped to 1. Therefore, this basis element will be mapped to 1. But
And diğer son eleman değil.
son eleman yok ki, sonsuz tane var. Sen bütün olayı kaçırdın. Değil mi? Bütün hikaye zaten sonsuz tane ise bu iş oluyor. Aslında takıldığın yer o yüzden önemli. Sonlu tane olsaydı bunu yapamazdın. Değil mi? Sonsuz tane olduğu için bir tane daha torbadan çıkartıp başımıza bela ediyoruz. So, this is what is this now? Okay. This is lambda 1 times E1 star E1 plus 1. Lambda 2 times and so on. Lambda n times En star En plus 1. So, but you know, En plus 1 is bigger than all of them. So these are all 0. 0, 0, 0. So this is 0. And 1 is equal to 0. This is the end of 0. Right? So contradiction. So V star is a vector space, but it has more elements than V. I didn't prove that, actually. We just showed that the expected basis for this star, the dual basis, actually is not a basis. It means you have to put more elements, right? This is the linearly independent set, but it is not enough to span V star. You have to add more elements. Okay? And it is not just one of them. Nerede? Burada mı? In linear algebra, a set is a basis if any element can be written as a linear combination, but that should be a finite linear combination. In algebra, all summations and products are finite. Okay? In analysis, you consider infinite sums, but in algebra, everything, all sums should be finite. Okay? We don't know what does this mean. Some of them are I from 1 to infinite. I don't know what does this mean. Okay, in linear algebra, this is not a well-defined object. Well, of course, you may define it, but at least at this level, we don't consider anything like this. For us, everything is finite. I mean, sums are finite sums. Tamam mı? Dolayısıyla sonsuz boyuta çıktığınızda işler değişiyor. Okay, so let's have a break.